I'm Anil Kumar, and in this video we'll explore applications of composite functions. It is an extremely important topic. Now we'll have many applications where we may have to write one function in terms of another function, and that is where composite functions come into picture. Let's take a few examples. Let us say that this is a pond, right? And there is a drop of water which just comes and drops here right somewhere in the pond. So as soon as the water droplets touch the surface of the pond, you'll find the ripples moving across. Now these ripples will move at a constant rate. So let us assume that the rate at which these ripples are moving is, let me call rate at which these ripples are moving as 3 centimeters per second. Let's give some value. Okay. So that is to say that the radius is increasing at this rate, right? Since the droplet touched the surface of water, right? Now, if we want to find how is the area related with the time since the droplet touched the surface of the water, then how can you find a relation? That is to say, we want to relate first radius in terms of time, right? And then we want to relate area in terms of time. Now to do so, what we can do is we can find relation between radius and time, since we know the rate at which the radius is increasing, and in our case that relation is, we can write down here, since the radius is increasing at the rate of 3 centimeters per second, we can say that the radius r is equals to 3 times t, where the units are in centimeters, right, and time is in seconds, correct? So that is the radius. Now how about the area? As far as area is concerned, we know area A is pi r square. Now this relation area as pi r square is in terms of radius. In terms of function notation, we can actually express both these equations as, let me use a different thing, and then we'll continue from here. Okay, so we can express these relations as a function f which is in terms of time t, right? And this function represents the radius as equals to 3t. And here we have another function g which represents area, but this function is given to us in terms of radius, right? So this function is in terms of radius, so we'll call this function as g of r, which is pi r square, correct? So that is how we have two relations at present. But what we really want is a relation between area and time. How do we make that function work out? So we say, what is r? R is the relation which is defined by f of t, right, as a function of time. That is r. This is r, right? So we can replace this with that function. So we get g of f of t. Do you see that? Since this function r is a function of time, we get our equation in terms of time. So we'll replace this f of t, which is 3t, for r. Do you see? For r, we replace this f of t, right? So we'll replace 3t with r. So we get pi, and r square means 3t whole square. You get the idea. So once we do that, we can write this as 9 pi t square. Now that becomes area as a function of time. So that is how, using composition of functions, we can write a function in terms of different variables. You understand? So we had radius in terms of time. We know area in terms of radius. Since radius is known in terms of time, we can substitute that area and that radius into area and get relation from area to time. Do you see that? Right? So let's take one more example to understand almost the similar thing. Now this time what we will do is, let's take an example. Let us say there is a radar, right, which is tracking airplane. And let us assume that the airplane crosses over the radar, and let's say this distance is 5 kilometers. And let us assume that the speed of the airplane is around 600 kilometers per hour. So it's going in this direction. Now what do we need to find here is the distance between the radar and the plane at any instance of time. So we want this distance as a relation with respect to time, right? How can you get that? So let's develop two equations. First we can say horizontal distance. That is of the plane. Let us say it is s. Now this horizontal distance is related with the speed of the plane. 600 kilometers per hour means 600 t, right? So every hour it moves 600 kilometers further horizontally, right? That is how we can get this relation. The other distance which we are interested in is the distance between the radar and the plane, right? The diagonal of this, right? Now how can you relate diagonal? Now diagonal d is equals to square root of 5 square plus whatever this distance is, s square, is it okay? S square, square root. Now that is in terms of distance traveled by the plane horizontally. If I have to introduce functions, then I can say, let me write this as function s, right? So s in terms of t can be written as 600t, right? And distance in terms of s can be written as square root of 5 square is 25. Let me write 25 plus s square, right? Now I can develop a new relation combining these two. Replacing s with s of t, what do I get? I get distance of s of t. Do you see that? That is the composition of a function. That is the composite function. In that case, I have to replace this value for t. Do you understand? Here, so what we get here is 600. So d of s is square root of 25 plus s square. So instead of s, we'll write 600t. So actually I should have written 25 first. But now let me rewrite this so that I can use this equation. S square plus 25. Let me rewrite this. So instead of s, I'm going to write 600t. Do you see that? So that is how it works. You substitute one function into the other, right? So s is 600t. So we have 600t and whole square. That is the s square plus 25, which was 5 square, square root. So now the function which you get is in terms of time. And how did we get it? We got it with the help of composition of functions. So distance of aircraft from the radar as a function of time can be given as square root of 600t whole square plus 5 square or 25. I hope with these set of examples you kind of appreciate how important it is to understand composition of functions. We'll have now many examples followed by this video. Go through these examples, but the concept remains same. That is, you have to write functions in different variables and then combine them to compose a new function, right? So that helps to write an equation in just one variable, and then it becomes easy for us to simplify. That's the whole idea. This is an extremely important application which will find massive use in calculus and functions. I hope that helps. Thank you and all the best.